Hello everyone, welcome to this series of mathematics lessons. This is a continuation of the previous lecture. Now let us discuss Euclid's 5 postulates. Postulate 1. A straight line may be drawn from any one point to any other point. A straight line could be drawn from any one point to any other point. This postulate tells us that at least one straight line passes through two distinct points. Say there are so many points here. Let us concentrate on these two distinct points. A straight line passes through two distinct points. But it does not say that there cannot be more than one such line. However, Euclid has frequently assumed, without mentioning, that there is a unique line joining two distinct points. We can restate this statement in terms of axioms. Given two distinct points, there is a unique line that passes through them. Generally, postulates are referred when we are dealing with geometrical ideas, and axioms are used in the context of whole mathematics. It is not only restricted to geometry. Now let us see this diagram. There are 2 points P and Q. How many lines passing through P also passes through point Q? Many lines passes through P and many lines passes through Q. And there is only one line which passes through these 2 points. That is line PQ. And how many lines which passes through Q also passes through P? Many lines passes through P and many lines passes through Q. There is only one line which passes through both P and Q, that is line QP or PQ. Both are same. Postulate 2. A terminated line can be produced indefinitely. Here we can see point A and point B, and we draw a straight line between them. Line is terminated, but it can be produced indefinitely if we extend the line along B and if we extend the line along A. A terminated line can be produced indefinitely. A circle can be drawn with any center and with any radius. All right angles equal to one another. This is obvious. All right angles are equal to one another. Postulate 5. If a straight line falling on two straight lines makes the interior angle on the same side of it taken together less than two right angles. Two right angles, the sum of two right angles is 180 degree. Then the two straight lines, if produced indefinitely, meet on that side on which sum of angles is less than two right angles. So basically what the statement is, say there are two lines, and if a line which intersects both the lines, if the interior angles on the same side is equal to 180 degree, then these two lines do not intersect each other. If a line intersects these two lines, if a line intersects these two lines, and if the interior angles on the same side is less than 180 degree, the sum of these two is less than 180 degree, then at one point these two lines intersect. Now let us notice postulate 5. Postulate 5 is more complex than previous postulates. If we notice postulates 1 to 4, if we see the postulates 1 to 4, a straight line may be drawn from any one point to any other point. Second postulate, a terminated line can be produced indefinitely. A circle can be drawn with any center and any radius. All right angles are equal to one another. These are self-evident and it is obvious truth. Even though those postulates are simple, it is very difficult to prove. So these statements are accepted without any proof because of its complexity. Nowadays, postulates and axioms are used interchangeably in the same sense. A system of axioms is called consistent when no other axiom contradicts a given axiom. A system of axioms is called inconsistent if any one of the axiom contradicts a given axiom. If an axiom or a postulate could be proven mathematically, then an axiom or a given postulate is called a proposition or theorems. If you can able to prove them, if you are able to prove an axiom or postulate, then that given axiom or postulate is called proposition or theorem. Now let us see example 2. Prove that an equilateral triangle can be constructed on any given line segment. Line segment has two endpoints, whereas line have no endpoint. We are talking about a line segment. In the above statement, a line segment of any length, say for instance AB is a line segment of some length. Now let us draw a circle with A as a center and AB as a length with length AB. Then we will draw another circle with B as a center and BA as a length of radius. Draw a circle. We will get an intersecting point. Connect these two points. We formed an equilateral triangle. The point of intersection we will call it as C. So we constructed an equilateral triangle ABC. We have to prove that this triangle is equilateral. In equilateral triangles, all sides are equal. In equilateral triangle, AB is equal to AC is equal to BC. Length remains the same. Length of sides remains the same. Now AB is equal to AC. AB is equal to AC because they are radii of same circle. You know that AB, we constructed a triangle with A as a center and AB as a length. We drew a part of circle. This length in a circle, radii is always same. If we take a certain radius and draw a circle using the same radius, at all point radius will be same. So AB is equal to AC. Similarly, we drew a circle with B as a point, taking B as a point and AC as a radius, we drew a circle. So the length of AB is equal to length of BC because these two radius are part of a same circle. So AB is equal to BC. From these two facts and Euclid's axioms, that things which are equal to the same thing are equal to one another. So we can conclude that AB is equal to AC, AB is equal to BC. If AB is equal to AC and AB is equal to BC, AC must be equal to BC, right? So AB is equal to BC is equal to AC. Triangle ABC is an equilateral triangle. Two distinct lines cannot have more than one point in common. Now let us take an example. We will draw two distinct lines. There is one point in common. Now let us draw again two more distinct lines. In this case, there is no intersection point because these two lines are parallel. Now let us take one more example. In this case, there is one intersection point. Two distinct lines cannot have more than one point in common. Here we are given with two lines L and M. We need to prove that only one point in common, not more than that. Now let us assume that two lines intersect two distinct points, say P and Q. Say for instance, these two lines will intersect at point P and Q. So, two lines passing through two distinct points P and Q. So, two lines passing through two distinct points P and Q. We are just assuming it. But this assumption clashes with the axiom that only one line can pass through two distinct points. Only one line can pass through two distinct points. So the assumption that we started with, that two lines intersect in two distinct points, is wrong. From this, what we can conclude? We are forced to conclude that two distinct lines cannot have more than one point in common. The content of this recording is borrowed from Karnataka Textbook Society, Bangalore, under Fair Usage Policy. This video is presented by Avvari Technologies. Please do hit subscribe button to get more content. Thank you.